Question 1. So the probabilities have to add up to a whole, so it's going to be 1, take away these 3 added together, so that gives us 0.2. Now for part B, Janice is going to play the game 50 times. How many yellows would we expect? Well, the chances of a yellow with one throw is 0.24, so if we throw it 50 times, we're going to expect 50 lots of 0.24, which is 12. Question 2. So these add up to 0.85, so these two here together must be 0.15 because the 4 together have to add up to 1. So 2x plus x equals 0.15, so 3x equals 0.15. Divide both sides by 3, we get x equaling 0.015, 0.05. Now, Olu takes a counter from the bag, he writes down the count of the colour, he puts the counter back in the bag, does this 50 times, estimate the number of times would take a red. So chances of a red with one pick is 0.6. So how many reds if you pick 50 times 0.6, which is 30. Question 3. So 3/5 is the chance it will land on a 6, and not landing on a 6 must be 2/5, because these must add up to a whole. And then a repeat of these probabilities the second time around. The second throw has got the same chances as the first throw. So 3/5, 2/5, 3/5, 2/5. Now part B, work out the probabilities Seb only rolls 1 6 in the 2 throws. So how can he get just 1 6? Well, either this yellow path here, which would be a 6 and then not a 6, or alternatively this brown path here, not a 6 and then a 6. So these are the two paths we're focusing on. So the yellow path first of all, 3/5 and then. Question 4. So from the round pencil case, the chances of a blue is 4 out of 7 and a red is 3 out of 7. And from the square pencil case, chance of a blue is 3 out of 8 and a red is 5 out of 8. So probability takes both red, so we need a red and then another red. 3/7 times 5/8, which is 15 over 56. Question 5. So the chances of a red is going to be 0.3 because the two together have to add up to a whole, and then these are repeated with the second spin. Probability of spinner lands on two different colours, so this could be green followed by a red, so green and a red, or it could be a red followed by a green, a red and a green. So green red, so green and then a red is 0.7 multiplied by 0.3, which is 0.21, or alternatively red and then a green, 0.3 times 0.7, which is another 0.21. We don't mind whether it's green red or red green, so we add these probabilities together, giving us 0.42. Question 6. So you just have to be a bit careful here as you fill in your probabilities. So on Monday, the chances that it will rain is 0.6. So not raining must be 0.4. The two together have to equal a whole. Now we're told that when it rains on Monday, probability it rains on Tuesday is 0.8. So if it rains on Monday, chances of it raining on a Tuesday is 0.8. So the chance of it not raining on a Tuesday, if it's rained on the Monday, must be 0.2. Again, these two have to equal a whole. However, when it does not rain on a Monday, so down here, probability it will rain on a Tuesday is 0.5. So not raining when it hasn't rained on the Monday must also be 0.5. Again, these two having to add up to a whole. So work out the probability of rain on both Monday and Tuesday. So 0.6 times 0.8, which is 0.48. Now for part C, work out the probability that it will rain on at least one of the 2 days. Now what we could do, we could work out this branch ending here, add it to this one ending here, add it to this one ending here. That would be absolutely fine. So 0.6 times 0.8 plus 0.6 times 0.2 plus 0.4 times 0.5, that's fine. But a quicker way is to say the only event we're not interested in is where it doesn't rain on both days. So the only branch we're not, or the only journey we're not interested in. Question 7. So the chance of a grey sock for the first sock is 3 out of 10, because these two have to add up to a whole. Now if a brown sock has been picked as the first pick, as we take our second sock, one of the browns is gone. So the chances of a brown is now going to be just 6 out of 9 because one's already gone, where the chances of a grey sock, well, there are still 3 grey socks to pick from, but out of 9. Again, notice how these two branches still add up to a whole. 6/9 to 3/9 is a whole. Now if, however, we've taken a grey to start with, what's the chances of the second sock being a brown? Well, there's still 7 to choose from out of 9, but one of the greys is now gone, so the chances of a second grey is now 2 out of 9. And again, note how these two branches add up to a whole. Now part B, work out the probability that Bevan takes 2 socks of the same colour. So that could either be brown brown or it could be grey grey. Now the probability of brown brown is 7 to... Question 8. Part A1, use the information in the table to complete the box plot. So we have the minimum value, we have the lower quartile, we need to include the median, which is the line within inside the rectangle. Well, that's at 11, so pop that line in at 11, that's 2 squares past the 10. Now we've got the upper quartile here, and then so the greatest number has got to be 22, so include 22 as the upper whisker. 22 is 4 squares past 20. So that's completing the box plot. Now we've got to complete the tables. So the smallest number is here, and that is 3. Now the upper quartile is where the rectangle ends, that's at 17. Right, now part B. Some of these 60 lemons have 8 or more lemons on them. Find an estimate for the number of lemons with 8 or more on them. So 8 or more. Now the lower quartile comes at 8, so 8 is a quarter of the way up. Question 9. So just filling in the box plot. So our lowest value is at 1.5, Our lower quartile, so where the rectangle begins, is at 2.7. The median is at 3.2, so that's the line inside the rectangle. Now the upper line on the rectangle has got to be the upper quartile. Now the upper quartile is what you get when you have the lower quartile add the interquartile range. So this upper quartile is going to be at 2.7 add 1.7, which is 4.4. So that's here, because upper quartile take away lower quartile, 4.4 take away 2.7 is what the interquartile range is, which is 1.7. And then finally the highest value comes at 6.3. Question 10. So 80 children in the group, work out an estimate for the number of children who weigh 52 kilograms or more. Now 52 is the upper quartile, so we're saying a quarter of the children are above this, 3/4 are below this. So a quarter are above this weight, a quarter of 80 is 20. Question 11, part A. The interquartile range is the upper quartile, take away the lower quartile. So where the rectangle ends, take away where the rectangle begins. So 166 take away 158, which is 8. Now for part B, let's just break this data up. So 170 is the median, because that's the number in the middle. Now to find the lower quartile, you just look at the numbers below the median, and we've got 1, 2, 3, 4, 5, 6, 7 of those, and find the middle of those 7 numbers, which is the 164. So that's the lower quartile. And similarly, to find the upper quartile, you look at the numbers above the median and find the middle point of those, which is the 175. So 153 is the smallest value. That's where the whisker starts. The beginning of the rectangle is at is the lower quartile, so that's at the 164. The middle line in the line inside the rectangle, no reason at all why it needs to be in the middle, is the median, so that's 170. And then the rectangle finishes at the upper quartile, which is 175. And then finally the highest value is at 186. Now question 12, so similar to question 11, break the data up. So the median is 28, and the middle number of the lower half is 20, middle number of the higher half is 42. So lowest value is 16, lower quartile is at 20, that's where the rectangle begins. 28 is the median, is the line inside the rectangle. Upper quartile, where the rectangle finishes, is at 42, and then highest value 50 is where the box plot finishes. So part B, then we're given the distribution of the ages of the men. So again, we're being asked to compare the distributions. So again, one comment on median, one comment on either range or interquartile range. So I've said the men have a higher median age. They do, because 36 is higher than 28. But the women have a higher range. Now the range for the women is 50 take away 16, which is 34, whereas the question 13, so we have to work out an estimate for the mean. Now we don't know how long the friends actually took to get to work. These three friends took anything between 0 and 10 minutes. So the best we can do is take a stab in the middle. So we take the midpoint of 5 minutes. So our starting point is to get a column of midpoints. So halfway between 0 and 10 is 5, halfway between 10 and 20 is 15, and so on. So from then onwards, we're going to assume that's exactly how long they took to get to work. So 3 friends took 5 minutes, 8 friends took 15 minutes, and so on. So we then cross multiply. We do 3 times 5, 8 times 15, and so on, giving us the subtotals. Question 14. So we're trying to find the class interval. So that means one of these categories that contains the median. Now the median is the middle height, so the height of the 40th child. 80 divided by 2 is 40. So we've already got them grouped by height. So here's 4 kids, so we haven't got to the 40th child yet. Here's another 11 children, so how many children is that in total? Well, 4 out of 11 is 15, still haven't got to the middle child. Here's another 24, 15 out of 24 is 39, still haven't got to the 40th child. Go into the next row. Question 15. So the class interval containing the median. Well, how many have we got? How many growths of mould have we got in this experiment? So add up the frequencies and we get 35. So half of 35 is 17 and a half, round up 18. So we want the 18th growth of mould. So again, these are in batches. So is our 18th in the first 4? No, it isn't. Add another 7 on, where we've now got to 11 growths of mould. Still haven't got to our 18th. Add on another 9, well, we've now got to 20 growths of mould. So yes, we've got to our 18th. Our 18th